Hello and welcome to the second part of page 2. This is gonna be the basis of example 2, so that's why it's broken up this way. All right, so now we're going to talk about defining the triple integral over a general bounded region. And so basically, when we're defining these integrals, the first thing that we want to do is we want to be able to define the region, and the kind of the region that we're whatever solid that we have, what are regions in between. And so here it's called a type 1 solid region, but I'm never going to say, hey, do a type 1, do a type 2, do a type 3, because, it doesn't really matter what you call these. Just make sure you know what regions you are. So here, in a type 1 region, you're defining your space between two z planes. And so here you can tell, z, the above portion, and z below. So that's going to define, the space that our object is in between. And so that's the first thing that you want to do, is you want to be able to define, that region in 3 dimensions. And so, what's the top half, what's the bottom half? And then after that, then it's going to be like a double integration. You're going to find, okay, well, what is the area on a certain plane? And so here we're defining this by the xy plane down there. That's what we're going to be in between. So that's the double integral part. So let me change that. So the double integral part is like kind of the part that's in pink, and then the parts that I circled in red, that's going to be the region that we're going to be in between. So when we're doing a type 1, our dz, all right, it's always going to be the first portion that we're going to take care of. So here, that's the portion that's going to be defined by between two regions. And then always that last portion, you want that last portion to be in between, two integers. All right, you don't want to, finish and still have a remaining variable. So you always want that last, region, that last part, in x, y, or z. You always want that last part to be defined by integers. All right, and again, since dz is, what's helping us define, the spaces that we're in between, what happens is a type 1 is where dz is finding it, and then dy dx can be interchangeable. I meant to circle, not do whatever just happened. All right, the dy dx can be interchangeable, so that's why here the first one you see dy dx, the second one you see dx dy. What makes this a type 1 is that dz is helping us define that region in the 3-dimensional sense. All right, so let's evaluate the triple integral. So evaluating the triple integral, pretty much it's already defined for us. It tells us, how we want to set this up. So we're going to be in between. This is going to be a type 1. So I'm going to go ahead and set up this integral. Because y is between two integers, 0, 1, y is going to be the outside integral. The in-between integral is going to be x, which is going to be from y to 1. And then the z is going to be our outside z to xy. And of course, that's defined by both of the other variables. And we're dealing with e to the zy. And so then we're going to have dz, dx, dy. All right, so let's go ahead and do the integration. So the integration for the first one, where we have z over y, we take the integral of that, and this is again where the u substitution would be 1 over y. So what we're missing is we're missing a y in front. So let's go ahead and integrate 0 to 1, y to 1, and so we have y e to the z over y from 0 to x, y, dx, dy. All right, let's go ahead and clean that up. So 0 to 1, y to 1. And plug in xy for z, and it's going to cancel out the y. So we get y e to the yx. I'm sorry, e to the x. Y e to the x. Minus. And then e to the 0 is just 1, so minus y. And that's going to be dx dy. All right, let's integrate this. So we go from 0 to 1. that should be dx right there. So now integrating this with respect to x, that's just going to be y e to the x minus xy from y to 1 dy. Let's go ahead and clean that up. 0 to 1. Plug in 1. So we get e to the y, ey, minus y, minus y e to the y, minus y squared. Let's go ahead and just take care of that minus. So that's going to be minus, so that'll be plus, because there are no like terms. And then I'll just go ahead and be able to integrate that, so dy. All right, so integrating that is going to give us e to the y. It's going to give us 1/2 e to the y squared. Not e to the y, ey squared. Minus 1/2 y squared. Minus here is a product rule. So that's going to be e to the y, derivative of e to the y is just e to the y, so y e to the y. Plus 1/3 y squared is going to be 1/3 y cubed from 1 to 0. Sorry, I'm just looking at something just to make sure everything is correct. All right, let's go ahead and plug in. So let's plug in 1. It looks like we're going to get 1/2 e minus 1/2 All right, so looking at this, that should be a negative. So that's going to cancel out what's going to be on the inside, so plus 1/3. And then plug in 0. The only thing that we're going to get there is just going to be that e to the y, which is going to be 0. So it's going to be plus, and so it's going to give us minus 1. And that gives us 1/2 e minus 7/6 when we